Hi everyone, welcome back to another video. So for this video, I will be showing you how to calculate the test statistic for t's. Okay, so the t test statistic. So this is the formula we'll need. So this is going to be the mean of the sample size. Mean of the sample. The n is the sample size. S is the standard deviation for your sample. And this is going to be the value that you're going to be testing against. What does that mean? Well, you'll see when we get to the problem. Okay, so this is the problem here. So this is the data right here. As you can see, pasted in. So first thing we'll have to do is get these two values. So I'll do that. Mean and standard deviation. We want one S for a sample. Okay, now the mu is going to be given to you in the problem. Okay, so that's going to be, for this one, is 33. And then the sample size, usually like me, count. Okay, oops, I forgot to put one in here. Okay, so now we're just going to follow that formula. This one right here. So what we'll do is, and this is where the parentheses are important too. Parentheses open, we want to do the subtraction first. So we'll take this, the sample mean, subtract it with the mu, close that parenthesis there, and then we want to divide. And just to be safe, we'll do the parentheses one more time. I'm going to take the sample standard deviation, and we're going to divide that by the square root of the sample size. And we'll just close all the parentheses now. And then test right there. Now to get the p-value, that's going to depend on what the test actually is. So I'll do all three, so you can see all three, because we got three different scenarios depending on what your alternative hypothesis says. So if you're looking, if your test is, for example, like this one, it's a left-tailed, we want the left-tailed probability. So that's going to be a t dist. See? It gives us the left tail. So we take that. We want the test statistic value for the x. Okay, your degrees of freedom is going to be your sample size minus 1. And we always want cumulative for this. Okay, so that is the left-tailed probability here. Now, if it was the opposite way, like this, right-tailed, then we just do t dist right. This will give you the right tail probability. So all the information will be the same. So that's the x, the test statistic. Degrees of freedom will be, again, sample size minus 1. And you notice there's no cumulative for this one. And that's the right tail probability. So as you can see, they should be complements of each other. Okay, and the last one is two-tailed. So that's this one here. Okay, so it's just like the right-tailed. So we use our test statistic as the x. Degrees of freedom is a sample size minus 1. Oh yes, one thing I also forgot to mention is when you're doing the two-tailed, it won't take negative t-scores. So you're going to have to do really quick. have to take the positive value, so we'll do the absolute function, absolute formula in here, and then we'll put in the degrees of freedom again. There we go. So that will be the two-tailed probability. Okay, so recapping. So this is the left-tailed. You want the t-dist. You always want cumulative. Remember, degrees of freedom is a sample size minus 1. Right-tailed, you don't have to worry about cumulative, but the first two will be the same. For the two-tailed, you got to make sure that you got a positive test statistic in there. Otherwise, it won't work, as you saw earlier. Okay, and let me just show you that formula one more time. So that's the formula there, so you might want to write that down if you don't already have it. Otherwise, you can just Google it, then you can write it down. Alright guys, well that's it for this video. Thanks for tuning in, and I'll see you for my next one.